I'm waiting for the student to join. Okay. After that, I'll introduce myself and represent the lectures. I'll wait for 2 to 3 minutes, then I'll start my lecture. Hi Swati TS. I thought this is your real name. So, am I audible and visible to you? Just give me a thumbs up, or if I'm audible and visible to every one of you, just give me the message in the chat box, or you just can raise your hand if I'm audible and visible to. Yeah, guys, I'm waiting for your response. You can just message me out. You can just use your chat box. Yeah. Okay. So, as you guys are not responding, that I would be considering that I am audible and visible to you both. Okay. So it's already 10 minute has gone. So yeah, thank you, ma'am. It's already has 10 minute has been passed. So without wasting so much of time, I will just start my lecture. Yeah. So are you guys able to see the screen? Actually, you are not responding to that is why. If you are having any trouble, just write it in the chat box. Okay. Yeah. So here we are with the lecture number 2 with geometrical optics. Okay. So yeah, what we have to do now, what is the aim for today in our class? We just recall things that we have done in the lecture 1. Okay. Then the deviation part that has been left in the lecture 1, it is added in this lecture. Now, then we are going to learn about object and images. Then plane mirror and image form. And after that, we will see the relation between velocity of image and object and do some numericals on it. Okay, so this is up for today. So let get it done. So firstly, we recall something that we have learned so far in ray optics. So firstly, we will deal with what is ray. मैंने बताया था कल आपको what is a ray. Ray is nothing but a straight line in which along with the light move, okay, in an homogeneous medium. Okay. What is a beam? Beam is a group of or bunch of rays, okay, which is put together. So that is a beam. There are types of beam we have. So we have convergent beam. What is the convergent beam? This is a beam which appears to meet at a point and move toward the point. Okay. Let me just draw it for you. So this is kind of the this is the direction of, and this is the point of convergence. Okay, so this you can recall it as convergent beam. Okay, so moving on to the next, it is the divergent beam. It is same as the convergent, but the direction is opposite. Okay, it is also meet or appear to meet at a point but move away from that point. So if it's that point, it will go like this. Okay, so this is the divergent part. It is just in opposite to the convergent, so it is divergent. Now what is parallel beam? Parallel beam is nothing but a group of rays which is parallel to each other. So these are the rays. Okay, now move on to the next. We have done with properties of light. Few important property that I would be point out here is the speed of light in vacuum, which is 3 into 10 raised to the power 8 meter per second. It depends on the medium. The speed of the light depends on the medium. If you change the medium, the speed of light will change. Okay. The next point is the light is an electromagnetic wave, okay, consisting of electric field variation and magnetic field variation perpendicular to both. Okay. So it go like this. If this is the variation of you say electric field, and this is the variation of magnetic field. So it will go in this direction and this. These are mutually perpendicular in direction. So yeah, light carries energy and momentum. Okay, because one theory suggested that the light is nothing but a particle having very fast speed. Okay, so it carries energy and momentum as well. So the formula V is equals to F lambda where f is the frequency, lambda is the wavelength, is applicable to light. Okay. So when the light gets reflected through some medium, there is a change of frequency, speed, and wavelength. But no, if this is reflection, then there is no change of frequency, speed, and wavelength. Okay. And no change of intensity if it is a perfect reflection. Okay. But we do not generally have the perfect reflection. All do we have is the diffuse reflection, I have told you. Okay. So in that, speed will not change, but the other parameters like the intensity will change. Okay, because some of the part of the energy of carrying with light is gone to the medium also. Okay. Yeah. So the reflection of light, you have seen it. What is it? When the light ray is sent back to the medium from where it is coming, after the interaction with the boundary, light is coming, it is interacting with boundary and going in the particular direction. Okay. So that phenomena is termed as the reflection of light. Okay. So it will also depends on the boundary. Okay. I must tell you that boundary can be rigid. This boundary can be a rigid boundary or just an interface. Okay. Rigid boundary, you must say the boundary of wood, boundary of a glass. Okay. And interface, you can say the interface between air and water. If this is there is a uh, there is a container having water, then if you strike the light to it, it will interacting with the interface only, because above on the of the water is only air and below is only water. So there is only one thin film of air and water interaction. Okay. Two types of reflection that we have. First one is the regular one and second is the diffuse reflection. So what is the regular reflection is? Yeah, just a second. Okay. So what is a regular reflection is? Regular reflection is nothing but when the reflection is taking place from a smooth surface, flat surface, that is regular reflection. Okay. It is from the flat and smooth surface. That is the regular reflection. All the properties that we have learned in properties of light will applicable to it. The frequency, wavelength, intensity will not change. But for diffuse, it is a rough one. Okay, the reflection will take place in rough surface and it goes in each and every direction. That is why we are not able to see our image in the newspaper or in wood or in your notebook also. Okay, because the surface is rough, so the reflection taking place is not in a particular direction, it is going somewhere in every direction, like every part of it. Okay, that is why we are able to see the things by every angle, in every angle. Okay, now the laws of reflection that I have told you. Firstly, this is the incident ray. This is the incident ray that we have. This is the reflected one. Okay, and this is the surface that we have, and this is the normal to the surface. Okay, I have told you this angle is angle of incidence, this angle is the angle of reflection. Okay, but these both the angles, angle I is equals to angle R. Okay, all the guys that is been joining now, I'm welcome you all in this class. Okay, if you have any trouble, if you have any doubt what I'm teaching you, you can just raise your hand or you can just send me the messages. Okay, so the law of reflection, we have two law. First is the incident ray, reflected ray, and normal ray. Three of them will lie in the same plane. Okay. The second one is the angle of incidence is always equal to the angle of reflection. These two laws. This is a very simple law. Okay. This is all about the law of reflection we have. Okay. The first thing that one thing that I want to tell you, that there is a term is normal reflection. What is normal reflection? Okay. Normal reflection में क्या होगा? When I is equals to 90 degree, means this is the surface you have and the ray is incident perpendicular to it, then it will move back in that direction also. So this is the normal reflection. And the another one is the grazing. grazing reflection. What is it? If this is the surface you have and a ray is passed just tangentially to it, means I here is, what is the value of I if you calculate this? You have just extended the I to this point. Okay, so I will be here is 90 degree. Sorry. Yeah, sorry, I'm sorry to forget the I here is the 0 degree. Okay, here is the I is 90 degree. Okay, small silly mistakes. huh? You have also remembered this silly mistake part. Okay, got it. There are two new terms to you, right? Normal reflection and grazing reflection. Normal reflection में क्या होगा? When I is 0, normal to the surface, going back normal to the surface. Grazing reflection में क्या होगा? It is touching the surface. Okay, moving tangentially to the surface. I is 90 degree. Okay. Any problem? Just ask in the chat box. Okay, so we are here with the deviation part. What is deviation? Deviation is nothing but, look, this is the incident ray coming. This is the incident ray coming. Okay. And there is a ray, reflected ray. What if I tell you, if there is no surface, this surface is not present here, what will happen? This ray directly goes to this place. Okay, but due to this surface, this ray reflected back and changes its path. So with the deviation part, what we are going to do, we are defining the reflection as the angle between the reflected ray and the ray without reflection. Okay, so you can also read the definition of it. When the light ray suffers a reflection, okay, there is a change in angle, okay, in the direction. So the deviation, what is the deviation is the angle between the direction of reflection ray and the direction before the reflection. Okay, so this is the direction before reflection, and this is the ray after reflection. After reflection. So here we define deviation as delta. So what is delta over here? You can say that this angle is I, this angle is also I. Okay, and this complete angle, let me just change the color of this. This complete angle, this complete angle is the 180 degree. All of you are aware about this. Okay, so what we are going to write, we are going to write the relatable terms in terms of 180 degree. Okay, so what we are going to do here is this I, angle I plus delta is equals to 180 degree. If you have any doubt, you can ask. This I plus I and delta. Okay, what is the value of delta then? It is 180 degree minus 2I. Okay, so this is the formula for deviation, or you can also write it is in terms of radian. So it is pi minus 2I. So this is the radiation. Sorry, this is the deviation part. Okay. So deviation is nothing but the angle between the reflection ray, the reflected ray, and the incident ray without reflection. ठीक है, सिंपल सी बात यह याद रखनी कि रिफ्लेक्शन के बाद रे जहां पे जा रही है और रिफ्लेक्शन से पहले जहां पे रे जाती है, उनके बीच में क्या एंगल है, व्हाट इज द एंगल बिटवीन देम, दैट इज द डेविएशन. ओके, गॉट इट? I hope you got it. If you have any doubt, you can ask in the chat box. Okay. Now, moving on to the next case, what it is? Yeah. So when the incident ray is kept fixed and the mirror is rotated through an angle theta, the reflected ray rotate through an angle 2 theta. Okay. So let me just draw it, what I'm saying to you. Yeah. So like this is the mirror that we have. This is the mirror. Okay. And this is the another mirror. Not another mirror. This mirror is rotated through an angle theta. Initially, it has normal. It has normal to it. Okay. This is the normal N1 firstly. Okay, and this is the normal 2 on this mirror after rotation. So I'm representing it as n2. The incident ray is like this and going in this direction. This is the reflected ray and this is the incident ray. We have kept the incident ray fixed, but due to the rotation of the mirror, this reflected ray will change its angle. So this is the reflected one. This is r dash. Okay, if this angle is I, this angle is also I. Got it? Then if this angle is also theta. Okay, so what you can say here, this normal and this normal will also having an angle theta, because normal is also rotated with an angle theta. Okay, so from here 9 normal say what is the angle of incident ray? It is I. Look very carefully, it is I plus theta. So what should be the angle? This, because law of reflection suggested that this angle, incident angle, will equals to the reflectance angle. So it will also be I plus theta. So we are supposed to calculate here with the value of the angle between the new reflected ray. Okay, so we have the statement, if the mirror is rotated by theta, then the reflected ray rotated by 2 theta. So this is the reflected ray that we have. Just a sec. This is the reflected ray first wali, and this is the reflected ray second one. So the angle between them is delta. Okay, so I am trying to calculate this angle. What will be this angle is? Okay, so for now you can say that if you try to calculate this value will also belongs to 2 theta. But if you do this is I plus theta. Okay, what if I know this angle is unknown to us. Okay, this angle is I and this total angle is theta. This total angle is theta. This angle is I. So what is this angle? This angle will be theta minus I. So we can write here this delta is equals to theta minus I plus theta plus I. I and I will get cancelled out. Then delta is equals to 2 theta. Okay, if you draw this diagram 2 to 3 times, you will get it how these angles are managed. Okay, if you have any doubt, you can ask. You can just write it in the chat box. Otherwise, we will move further. Okay, I must tell you first again, the angle with the new normal is this I plus theta, because the normal is also rotated through an angle theta. Okay, so according to the law of reflection, this angle will become, with the new normal, incident ray will make I plus theta. So reflected ray will also make I plus theta. Okay, and this complete angle is theta, and this small angle covering this part is I. So what is this angle? This will be theta minus I. So we have the calculation. Okay, if you have any doubt, just write it in the chat box, or otherwise we will move on for the deviation by 2 inclined mirror. So simply it is nothing but here you can see that these are 2 inclined mirror over here. Okay, this angle is I. Okay, this is the incident ray. Just a second. Yeah, this is the incident ray. This is the reflected ray again, and this is also the second one. So here we have, like, firstly, there are 2 times of reflection taking place over here because there are 2 mirrors. Okay, so the first value first is the this way. Okay, so how the deviation is defined? Deviation is defined by the angle between reflected ray and incident ray without reflection. So this will be the angle. If this is 2i and this is the angle that we want to know, this total angle is 180. This total angle is 180. So this will become 180 minus 2i. Okay, this is the first deviation. Again, if you calculate this angle, what is this? Again, this is theta minus I, theta minus I. This is the deviation that we have. So what will be the value of this? Again, this complete angle is 180. So we have 180 minus 2 times of theta minus I. So from here we can say that we have delta. Deviation is delta 1 plus delta 2. Okay, this is equation 1. What is the value of delta 1 we have? We have 180 minus 2i. What is the value of delta 2 we have? We have 180 minus 2 times of theta minus I. Got it? Now, what is delta? Put these values in equation 1. We have 180 minus 2i plus 180, okay, minus 2 times of theta plus 2 times of I. Okay, got this? Yeah. So, here the delta will be this 2i and 2i will get cancel out to each other. So the delta will be 2 times of 180 minus theta. Okay. You can also write it as 2 times of pi minus theta. So this is the another formula that you have. Okay. Have any trouble with this? You can ask. Okay. Now move on to the next one is object and image that we have. Okay. So what is an object? Object is nothing but we. We are the objects. Anything that could create an image is an object. Okay. Like you click the selfie of yourself, you are the object then. You are the clicking the selfie to another one. You that person or that thing would be the object. Now in terms of ray optics, how we are going to define it? Okay. Object is nothing but the meet or the intersection of incident ray. Okay, got it? It is nothing but the what it is? It is the interaction, point of interaction of incident ray that we define as object. So you can write it as here. So there are two types of object that we have. I am a real object. I am not imaginary. You can touch me, not now, but if I'm visible to you, present to you physically, then you can touch me. Okay. Any object that you can touch is real, and any object that you can't touch is not real. Okay. So object is. Let me just tell you something about it. Okay. Suppose this is the yeah. Okay. ये अपने आप ही आ गया. Okay. इसी से ही पढ़ते हैं. So what is the yeah? This is the real object we have. This is the incident ray, and the point of interaction of incident ray is real object. I have said you will say always this side of the plane mirror is called the incident side. Incident side. Okay. So if any object lying in the incident side, it will be a real object. Or virtual image. I will tell you what is the virtual images. But for now, it is this point, these rays are not actually meeting here after reflection, but it appears to meet. So that is a virtual image. Okay, this side will be, okay, if the object is present on the incident side, then it will be a real object. And अगर ये दूसरी साइड में है, ये रियल साइड में नहीं है, इंसिडेंट साइड में नहीं है, then it will be a virtual object. That is that simple as this. Okay, like for this, the second part of this image, if you try to draw the intersection of this incident ray, these rays are coming, these are the incident ray. Okay, they are not interacting with the boundary yet. So this object is not lying. This is the object we have. This object is not lying in the incident side. So what it is called? It is called the virtual object that we have. Okay, it is the virtual object. Got it? So there can be two types of object. One is the point object, and another one is the extended object. So we are the extended object, and if the distance between the mirror and the object is too large, then it will consider it a point object. And another thing, if the size of mirror is too large in comparison to the object, then it is also considered as point object. And the extended object is this extended object. Okay, so there are two types of object that we have. Now in terms of image, what is the object? Object is the intersection of incident ray. So in opposite to that, image would be the interaction of reflected ray. Okay, so it is defined as the point of intersection of the reflected ray. There are types of image that we have. First one is the real image that we have. So if the rays are actually meeting, as we have seen in the earlier, you can see in the earlier example, these rays are actually meeting here. So this would consider as the real image. But for the upper one, these rays are not actually meeting, but appears to meet. Okay, so that would be considered as the virtual image. So this is simple definition that we have. Okay. Okay then. Examples of real image, a cinema screen. Okay. That could be the example of real image because there is a screen and the image is formed on there. The actual intersection is there of rays. So we can say the image that you perceive by the retina of your eyes is also the real image. Okay. And what is the virtual? अब तक जिस शीशे के सामने खड़े होकर के बाल बहा रहे हो, कंघी कर रहे हो, अपने आप को संवार रहे हो, ड्रेसिंग कर रहे हो, दैट इज द वर्चुअल ऑफ. ओके, दैट इज द वर्चुअल इमेज बिकॉज मिरर के पीछे क्या है? देयर इज नथिंग until and unless you have hide something there. Okay, from the eyes of your mom. अगर मम्मी की नजरों से बचा के कुछ रखा हुआ है, उसके अलावा तो कुछ नहीं है ना वहां पे. Are you really present there? No. So if you put a screen right behind your mirror, have you got your image there? No. So that is the virtual image. Okay. Image formed by the plane mirror. Simple. If you have any doubt, you can ask. Okay. Now, plane mirror and the object form by the point object and the extended object. So, yeah, plane mirror क्या है? Plane mirror is nothing but a polished surface. Okay, एक thin glass sheet होगी या कुछ भी हो सकता है ना. No, I'm not forcing you to be consider the glass. Anything could be a plane mirror. The condition is that one surface has to be polished and one surface is kept silvered. Okay, the light cannot be passed through it. Must be the reflection takes place there. Okay, so it is nothing but the thin glass plate. I have mentioned the glass here. You can consider anything as a plane object. Okay, so it is right now. If you are watching me through your laptop or tablet, there is an image forming in front of you of yours. It is not too clear, so that would also be considered as a plane mirror. Okay, so if I send a beam of parallel rays to a mirror, what will happen is like this is the just a second. There is some technical glitch having with me. Okay, so this is the plane mirror. This also represent the rough side of it, and this upper side is the polished one. Got it? So if a parallel beam of rays is set to it like this, so what it is, just recall it. This is the reflection, and what kind of reflection? It is the normal reflection. So what would happen? They will send back to their places. Okay, so that is why I have written in here is the parallel rays of light incident on a plane mirror will get reflected as a beam of parallel reflected rays. Okay, got it? Now, few things that I have to mention here. Okay, if this is the plane mirror that we have, this in point object, so the image of this, if the distance of this is from the plane mirror is d, so image bhi iski itni hi duri pe banegi, that is d. Image will also formed as at this distance, and this is the virtual image. That is it. Now for extended object, what is the value of extended object? Like this is the extended object, this is a, this is b. So again, there are infinite points through which uh, this extended object has been made. So there are infinite images that we got over here at the same distances, and if we join them, this will form a image of this extended object. Okay, at the same distance. One thing here is this is placed parallel to the mirror. तो पैरेलल में कुछ नहीं होगा, सिंपल इस तरह की ही ऑब्जेक्ट आपको मिलेगी. ओके, बट if the object extended one is placed perpendicular to it, like this is A and this is B, so what will happen to this? It will just reverse it. This is सबसे पहले B की बनेगी, then A की बनेगी, the same distance. That is the only difference. This is for the perpendicular one, perpendicular placed. Got it? Now, if you have any doubt, you can ask. Now the number of images formed by two inclined mirror, if they are inclined at some angle theta, so what could be the number of images? I will tell you through this table I have made for you. Look, there are two images, two mirror here. One is M1, this is M1, this is M2, and then inclined at an angle theta over here. Okay, this is the object. We have this blue dot you have seen here. This is the object. This object having alpha angle with this mirror M1 and beta angle with this mirror M2. Okay, so here we can say that theta is equals to alpha plus beta. Okay, so we have a formula, n is equals to 360 by theta. What is this n? I will tell you. Okay, you let us try with this an example. Okay, suppose this theta is here is the 90 degree, means the plane mirror are placed perpendicular to each other like this. So if I divide this, what will I get? N is equals to 360 divided by 90 is equals to 4. It is a odd or even? It is even number. Okay. So it lies in the first category. It is even. So position of object is anywhere. अब हमारा object कहीं भी placed हो. That is why I have mentioned these angles alpha and beta. Okay. So अगर this number n would come a even number, so मेरा object कहीं भी placed हो, how many number of images I will get? It will be n minus 1. According to this question will be n minus 1 is 4 minus 1, which is 3 images I will get. But if it is odd, then it will depend on the symmetricity of the object. For symmetric, alpha must be equals to beta, and for asymmetric, alpha is not equals to beta. So if I'm getting an odd number over here, then I have to check this alpha is equals to beta or alpha is not equals to beta. Okay, and according to that, the number of images will be. It is not n minus 1. I must have, yeah, mistakenly it is added here. It is n, only n. Okay, so keep remembering it. Sorry for the typing error. So it is n. Okay, so if I just take an example, like theta is equals to 40 degree we have, and we have alpha is equals to beta is equals to what? 20 degree also. So n we have 9, because 360 divided by 4 will be 40, will be 9. So we have n odd, and this also symmetrical because alpha is equals to beta. So how many number of images we will get? It will be n minus 1, which is 8. Okay. If you have any doubt in this, you can ask. Otherwise, we will move on to the next. So these are the few most important part of this chapter, the relation between the velocity of image and the velocity of object. Okay. Firstly, what we will do, yeah. Yeah. So in the first case, when the object is in rest, sorry, object is moving and mirror is at rest. Okay. So this is the object like we have, sorry, just a second. This is the object we have, and this is moving in this direction. And this is the plane mirror, which is kept stationary. So initially the image will be formed in this direction. This is I. Okay. And if this is moving in this direction, the distance between them is X, and this is also Y. So according to the image formation by plane mirror, what should you say? You can say X is equals to Y. And if you consider this direction to be positive, this is to be positive, and this is to be negative. Okay. So if anyone is moving in this direction would be considered positive, anyone is moving in this direction would be considered negative. So x is the distance of object, y is the distance of image. We would differentiate it with respect to time. Why? To get the velocity. Okay, velocity is nothing but the change of position, change of displacement. So it is dx by dt, and it is dy by dt. I would consider the sign over here because it is velocity. Okay, so this is the velocity of object, and this is the velocity of image. These velocities are equal but opposite in sign. Why we I mentioned this thing? Because this is perpendicular to perpendicular to perpendicular to what? These velocities are perpendicular to what? This is the velocity object, this is velocity of image. This is perpendicular to what? Perpendicular to the mirror. Okay, these velocities are perpendicular to the mirror. What if these velocities are not perpendicular to the mirror, these are parallel to the mirror? What will happen? Okay, again in this, if you have any doubt you can ask. Okay, so this is the formula that you have. Okay, now in the second case, I have just mentioned it here, case second. When object is moving, object is moving parallel to what? Parallel to mirror. I'm just changing the color for your better understanding, and you will differentiate it over what is for the perpendicular and what is for the parallel. So this is the velocity of object, this is the velocity of image. You can also say, अगर मैं शीशा लेकर के अपने हाथ को ऐसे रखता हूँ, हाथ की इमेज देखता हूँ, इफ आई सी द इमेज ऑफ, अगर मैं इसे ऐसे ऐसे कर रहा हूँ तो ऐसा थोड़ी होता है कि अगर आप ही जंप कर रहे हो शीशे के खड़े सामने खड़े होकर के, तो ऐसा थोड़ी होगा कि आप तो जंप कर गए लेकिन आपकी इमेज वहीं पे खड़ी हुई है, नहीं अभी मैं जंप नहीं करूंगी, ऐसा तो नहीं होता. बिकॉज द लॉ सेज दैट इमेज must be at the same place where the object is for plane mirror. Okay, so these velocities are equal to each other. Means velocity of object parallel is equals to velocity of image parallel. Okay, always in the direction also. But for the perpendicular one, these are same in magnitude but opposite in direction. I must write here the magnitude of VO is equals to magnitude of VI. Got it? Okay. This is the first case. Okay. If you have any doubt, you can ask. Now, you can ask by writing into the chat box. Okay. The second is the relation between velocity of image. Obviously, we are doing this. So what is this? This is a mirror moving. An object is at rest. Okay. Now the thing will change. Now we have mirror with certain amount of velocity and object is at rest. So here our object O, here it is image I. So in this case also both the cases are there. In the first case, if you pay attention to the lecture, in the first case, I have measured all the velocity with respect to the mirror, and mirror is at rest. So I am measuring the velocity of object and velocity of image with respect to rest, means with respect to ground. Okay, and with respect to mirror, the velocity of object and the velocity of image will never get change. ऐसा तो कभी भी नहीं होगा कि अगर this is the आपका mirror, this is your object, okay, and if you are going with the mirror, look at my hand, going with the mirror, the image would change or not? No, image would be at the same place because same amount the object has shifted, same amount the mirror has shifted. Means with respect to mirror, the velocity of object and the velocity of image would be same. So I'm using this concept right now because here the velocity we have a certain amount of velocity of mirror, which is the perpendicular one. Okay. So we can say here that velocity of object perpendicular with respect to mirror is equals to velocity of image with respect to mirror perpendicular are same. Okay. Not same, not same. बताओ क्या मिस है यहाँ पे? Just write it in the chat box. What I'm missing right now? I am missing with the sign because they are equal in magnitude but opposite in sign. Opposite in sign. Okay. So from the relative velocity knowledge, what we can say that velocity of A with respect to B is velocity of A minus velocity of B. Same we are going to write it here. Velocity of object perpendicular one, velocity of mirror perpendicular one minus velocity of image perpendicular one minus velocity of mirror perpendicular one. Okay, just multiply this minus inside. So we have velocity of object perpendicular minus velocity of mirror perpendicular is equals to minus of velocity of image perpendicular minus plus velocity of mirror perpendicular. These all are the absolute velocities. These are the absolute velocity. Means measured from the rest. Okay. So we can say here that velocity of m को इधर लेके जाएंगे, it will become positive, and velocity of image को इधर लेके आएंगे. Perpendicular plus velocity of image perpendicular is equals to 2 times of velocity of mirror perpendicular. Okay. So this is the relation that we have, or we can say it like velocity of mirror perpendicular is equals to the arithmetic mean of velocity of object and velocity of image perpendicular divided by 2. This is the final formula that we have. Okay, just keep this in mind. Okay, now if object is rest कर रहा है, हम ही हैं वो rest कर रहे हैं. ठीक है, so VO will be 0. So just put it here. VO perpendicular or parallel would also be. So velocity of mirror perpendicular will be, because this VO perpendicular will be 0 over here. So only VI will remain. VI perpendicular divided by 2. It will leads you to the velocity of image perpendicular is twice of the velocity of mirror perpendicular. Okay. Got it? This is it. Okay. And what if the mirror is moving parallel? Does it affect the velocity? Does it affect the position of the object and position of the image? No, because if it is moving, this is the object, this is image, and this mirror is moving like this. So what happened? Doesn't. Okay. So velocity of mirror parallel will have no effect. Okay. Got it? Yeah, this is it. Yeah. I have discussed it that object and mirror both are moving. So I am just going to write the formula over here. So this is the object. This is moving at certain angle. This is the object perpendicular. This is the object parallel. Same here is the for image. Same here for the image goes. So image over here is moving in this direction. Or otherwise we can say in this direction also. We just kept the general direction. So this has two component. This is the velocity of image perpendicular, and this is the velocity of image parallel. Although the mirror is also moving velocity with m. So this is velocity of m perpendicular, and this is velocity of m parallel. So we can write it here that velocity of object parallel is always equals to velocity of image parallel. Doesn't mean कि mirror move कर रहा है stationary या कोई effect नहीं है इसका. But velocity of object perpendicular plus velocity of image perpendicular is always equals to the, yeah, I have to mention the arrow over it because it is vector. So it is 2 times of velocity of mirror. Okay, got it. Now, yeah, find the velocity. I'm giving you this question, very simple question to you. Just answer it. Okay, it is a very simple one. Find the velocity of image. Okay, velocity of object given you as 5 meter per second. This is VO. Just a second. This is VO is equals to 5 meter per second. So image कहीं यहाँ पे बनेगा I. What is the answer to this question? Just write it in the chat box. I'm giving you 5 seconds. It is only a 5 second. At least 5 seconds से भी कम ही है question. What is the value of? Just write it in the chat box. Hoysala, very good Hoysala. It is very correct, yeah. Good. इसका मतलब है you are paying attention to the lecture. It's thanks to me, okay. Okay. Yeah, it is correct. VO is -5 because we have learned here what we have learned, that velocity of object perpendicular is equals to minus of velocity of object, sorry, velocity of image perpendicular. Okay, and this is the velocity perpendicular given to us. So what would be? It is minus Vi is equals to 5. Then Vi is equals to minus 5 meter per second. Only Hoysala is paying attention or anybody else? Okay, just let me know. I'm a very friendly teacher, yeah. I'm not like the strict one. Okay, the last question that we have. Yeah, it is, just try to solve this question. I am giving you 10 seconds. 10 seconds to this question. Although it is worthing more than 10. Okay. Okay. Parallelly, I will try to solve it. You just match this. We are given with the velocity of object over here. अरे अभी खत्म नहीं हुआ. Velocity of object is 5√2 and velocity of image is, sorry, velocity of mirror is 2√2. So what we are, we would find the velocity of image perpendicular and velocity of image parallel. Okay, these two they have to find out. So we would just resolve this velocity of object in two direction, in this and in this. So velocity of object perpendicular will be 5√2 cos 45. What is the value of cos 45? It is 1 by √2. So we have 5 meter per second, the perpendicular one, or the parallel one. Also, it is 5√2 sine 45. Okay, so it will also be 5 meter per second. So from the formula that we know that velocity of object parallel to the velocity of image parallel means velocity of image parallel is also 5 meter per second. Okay, and velocity of image perpendicular plus velocity of object perpendicular divided by 2 is the velocity of mirror perpendicular. Okay, yeah. So here we would take this direction positive, this direction negative. So all the velocities are in positive direction. So what is the velocity of image perpendicular plus velocity of object perpendicular we have as 5 meter per second. So V5 divided by 2 is equals to what? Velocity of mirror perpendicular. So we would resolve this. What is the velocity of mirror perpendicular? Will be the 2√2 cos 45. Okay, so 2 meter per second we have. So we have this 2. So yeah, this would be the velocity of image. Okay, and this will cause that 2 to the 4, and this we have 5 over here plus 5. So minus 5, sorry, minus 5 plus 4. So we have velocity of image perpendicular as minus 1 meter per second. Okay, got it? Also, it is very clear because object is moving in this direction. So uh, this image has to be moving this direction. Although this is up from my side. If you have any doubt, you can ask, or yeah. So if you guys are having any kind of doubt, you can ask, or otherwise the class is over now. Thank you so much for joining, and मुझे झेलने के लिए धन्यवाद. Thank you so much. Take care and rest. Okay, and also keep studying. Okay. Thank you so much, all of you. Thank you so much. Okay.